we are going to be doing an actual use of these radicals that we have been dealing with. So, Pythagorean's theorem. And I'm pretty sure you've done this before, pre-algebra perhaps. So here's the idea of Pythagorean's theorem. Let's get that down. So let's say I have a triangle. And it has to be, so this is the first little thing here, this has to be a right triangle. Well, what's a right triangle? It has a right angle. Alright, so the idea of this is having to do with area. So if I took this side, let's say I hash marked it. And I found this area. And then I extended this side, let's hash mark that. And I found this area. And if I took this area, and found it. So I have all these areas. I would find that they are all add up to the same. So this little box plus the medium box would equal the largest box. That's the whole idea of Pythagorean's theorem. We could do that on paper, cut it up, and you would see quite physically you could move this around and get this box and this box into this box. And it would fit perfectly. So, what does that mean? Well, if this side were A, then this side is A. So what's the area of that? The area of that's A squared. And if this side were B, then this side is B, then the area of this side is B squared. And then right here, C and C, this would be the area of C squared. So Pythagorean's theorem is A squared plus B squared equals C squared. Now, later in your mathematical career, you use this, but not with the same letters. Okay, so there's a better way to think of it. You think of it leg squared plus leg squared equals hypotenuse squared. That's a way better way to think of this. That way you're not getting fixating on these letters, because in different math classes, these letters might mean something else. So think of it as leg squared plus leg squared equals hypotenuse squared. So the other class, actually geometry, just asked this question, well, what's the hypotenuse? What is that? Well, in a right triangle, that is the longest side, so you can think of it like that. It is the longest side. But better is the side opposite the right angle. That's what the hypotenuse is. So if I draw another triangle, and I ask you, well, what are the parts of this triangle? Here's what I mean by opposite. Take a look so you don't miss this. You see this right angle right here? Look opposite it. The opposite side does not touch the angle. You can think of it like that. So this is the hypotenuse. See how it's opposite the right angle? That means this is a leg, and this other short piece is the other leg. All right, so let's try an example problem. I want to find the missing side exactly. And to the nearest 10. That way we're practicing both of those things. So I'll just write this. Let's say this is 50. Let's say this is 10. And this, I don't know. I'm going to erase this blue diagram right here. Alright, so we're going to write our formula. Every time we use a formula, we write it down. That way we memorize it. And we're using A and B to mean the legs. So, let's identify these parts. X, is that a leg or a hypotenuse?
Leg.
10 is a, and 50 is a hypotenuse. Okay, so I'm going to replace, it doesn't matter which one I put the 10 and X in, so I'll just put the X in for A. It doesn't matter, because it means leg squared plus leg squared equals hypotenuse squared. So 10 squared equals 50 squared. 50 squared, what is that? Use your calculator.
I accidentally calculator on
In a moment. Okay, 50 squared, what'd you get?
25.
Okay, and we have x squared plus 100, because 10 squared, now we subtract 100, x squared equals 2400. Now, what do we need to do in order to solve x squared? How do I undo, do you think, a square?
Square root.
A square root. Okay, so x equals the square root of 2400. Now here's where all that stuff that we did last section we're going to have to use. So I'm going to erase this little area here so that we can take a look. So I have to simplify that 2400 exactly. So I'm going to have to prime factorize it. So I could do a bunch of 2's, but that takes forever. So I'll do 100 times 24. But there are lots of different ways you could do this. You could have divided by 50. That would have worked as well. We'll divide this, 10 and 10. And then 5 and 2. 5 and 2. How about 24? Each of you do 24. Split 24 up.
Let's say 4 and
8 and 3.
4 and 6. Okay, 2 and 2. 2 and 3. Okay, so I'm going to rewrite the 2400 as 5 squared times
2 to the
2 to the 5th times 3. Now I need to split this up so it's divisible by what number? 2. Okay, so because that's my index, so 5 squared
times 2 to the 4 times 2 times 3.
Okay, so the square root, what can I actually take the square root of?
5.
Okay, and the rest has to stay. So the exact answer, I'm going to put it over here in the corner. X equals the square root of 5 squared is?
5.
Now, let's be careful. What's the square root of 2 to the 4? 2 squared, which is 4. And then what's left on the inside?
2 times 2 is 6.
Okay, so x equals 20 root 6. That's our exact answer that I asked for at the beginning. Okay, let's say I wanted an estimate. Well, I could get my estimate from this step, or I could get my estimate back here. I just put that in my calculator, and I said to the nearest tenth. So on my calculator, what is that to the nearest tenth?
48.49.
48.49?
0.98.
0.9. Is that what you said?
Somewhat.
What do you mean somewhat? Okay, read off the digits your calculator said.
48.9897.
Oh! Okay.
That's what I said.
Okay, so I said nearest tenth, so this 8 tells that 9 to round up. The 9 becomes a 10, I have to carry it over, so actually to the nearest tenth is 49.0. Okay, so I see what you were trying to avoid there, that tricky thing. It's alright though. Alright, we're going on. Let's do another example. This one we'll just do to the nearest tenth. Okay, so set it up. X, hypotenuse or leg?
Say, that's a hypotenuse.
Someone else. 3
Leg.
and 7. So I fill in my formula. 7 squared
Plus 3 squared equals x squared.
Okay, so I have 49 plus 9 equals x squared. So I get 58 equals x squared. Now what do I do to solve?
Square root of 58.
Square root of 58, I'll put that in my calculator. And to the nearest 10, what do I get?
You get 7.6.
6.
We all agree, 7.6? Okay. All right, that leaves us just one more thing that we need to do. We're going to ask is, or rather instead of is, do the 3 sides make a right triangle? That's the question that I'm going to ask for these next few examples. If they do, that means Pythag would work. All right, so let's say I give you the sides 1, 2, and 3. Now, if this is a right triangle, the 1 and the 2 are legs, and the 3 would have to be the hypotenuse, because the hypotenuse would be the longest side. So it would be 1 squared plus 2 squared, because I'm using Pythagoras' theorem to see if it works. So I don't know if it works. So I'm asking a question. Does a squared plus b squared equal c squared? I'm asking that. 3 squared. And 1 squared is 1, 2 squared is 4, and 3 squared is 9. And I'm asking, does 1 plus 4 equal 9?
No.
And the answer is no. So is this a right triangle? No, it is not a right triangle. Okay, maybe I'd give you 16, 34, and 30. Okay, so looking at these numbers now, I need to be careful. Which of these 3 numbers is the hypotenuse?
34.
No, 34.
The 34 is the hypotenuse, which means 16 and 30 are the legs. So I'm asking, is 16 squared plus 30 squared, does that equal 34 squared? Well, what's 16 squared?
256.
And what's 30 squared?
900.
And I'm asking, does that equal 34 squared when I add those? What's 34 squared?
1156.
And if I add these, 1156 does equal 1156. So I conclude, is this a right triangle? Yes, that's a right triangle. Now, I'm not going to go through the next example, but it's the same question. This same question worded a different way would ask, are the numbers a Pythagorean triple? And if they are, then Pythagorean's theorem works. So that's essentially the same question, just worded a different way. All right, I want you to get out your books and turn to page 550 or 587. Page 587, and we are going to do a bunch of practices of this.
Why do we have that one?